Okay, in this video, everyone, we're going to start looking at all that exponent stuff I've been kind of talking about in the last couple. This is that third lesson for Math 10, exponents and radicals. So we'll get into the radicals bit after we take care of all the exponent stuff. Now, a lot of these exponent laws do get presented in grade 9 math. So a few of them for sure are going to seem like they are review, like you've seen them before. But of course, as you know already, as you get up there in your math education, every year seems to add something else new to the pile. So, which is exactly what we're going to do here. So we'll talk about a little bit of review, some of those exponent laws, which you might have seen before, talk about a couple new ones, and then a ton of examples to illustrate how they're going to work for you. So we're just going to complete this table first. So we're going to have, I prefer actually, so I'll read out what that says. Complete the following table where A and B are rational or variable bases, and M and N are going to be your integral exponents. Now, I prefer really to avoid using A and B for the bases. Personal preference, it really doesn't change anything, but I'm going to use X and Y. And then for my exponents, that's where I just like to put A and B. It's just that's something that I started doing a long time ago, and it kind of stuck for me. So if you want to interchange them with A and B, X and Y, M and N, whatever letters you really want, doesn't make a difference here. It really is a personal preference. So we'll start off by talking about the product of powers. So if you think about what the law says, we're going to take the product, which means to multiply, and we're going to multiply two powers together. Now remember what a power is. A power has both a base and an exponent attached to it. So that's what we mean when we say a power. So we're going to take two powers. There's going to be one of my bases, so X, and that's going to be to the power of A. Okay, so as a power, the whole thing, X to the power A, or X with an exponent of A attached to it. And that's going to be multiplied with another base X, but with a different exponent. And I'm going to say B. Now, when you actually evaluate that expression, you have the same bases. So X and X are the same in both expressions, both parts of that. The exponents are different. So when you multiply powers with the same base, you're going to add those exponents together. Okay, so what was before X to the power of A multiplied with X to the power of B becomes X to the power of A plus B. Now, if you need an example with numbers to help, so let's say we have something like 2 squared multiplied with 2 cubed. You could also say that as 2 to the power of 5, okay, if you needed the numerical example to illustrate that. The word for division in math we give as a quotient. So when you divide two things, the answer you get is the quotient of that division. Okay, that's what we call it. So we're going to do the same thing. So let's say we've got X to the power of A over X to the power of B. The resulting answer there is going to be the difference in those powers. So you're going to have the same base, still X, but your exponent will be represented as A minus B. And again, if you need an example to illustrate that, let's do 3 to the power of 5 over 3 to the power of 2. That resulting quotient will be 3 to the power of 3, subtracting those powers. Okay, moving on, power of a power is going to be our third one. So what happens when we have some power, X to the power of A, and that is raised to a second power? The result there, you're going to actually take those exponents, A and B, multiply them together. Okay, a little bit different than the product of powers, so keep that in mind. We're not adding there. Because I've only got one base, those exponents will get multiplied. Since I had two bases in my product of powers, even though the bases were the same, I had to add them. Okay, but here, if it's a power of a power, I've got a power to a power, we're going to multiply. So that'll become X to the power of A times B. And again, we could say it's 4 cubed as a numeric example. That's to the power of 5. Now you could evaluate inside the brackets first. 4 cubed is 64, and then raise that to the power of 5. Or you could simply do 4 to the power of 15. Now this might illustrate for you that's going to be a really, really large number. Some calculators might not even give you the numerical answer because it's so large. Okay, what about a power of a product? Power of a product. So imagine that we've got a product, two things being multiplied together. And I'm going to say now that we've got x multiplied with y. Two things multiplied together. I don't see an exponent explicitly written there, so in math we always assume there's a 1. Just like for the coefficient of this x, since there really isn't anything in front of it, we assume that there is a 1 there. Okay, so just keep that in mind. So even though you don't see any exponents on that x and the y, technically there are 1s there. Now this is my product. Now we're going to raise that to a power. Let's say we're going to raise that to the power of a. Now what happens here? Now when we go to actually write out this product, what happens is that exponent of a is going to apply to each thing, each term, each item, whatever you want to say, inside that set of brackets. Now technically there's one term inside that set of brackets. A term in math is something separated by addition or subtraction. So since this is multiplication inside that set of brackets, it's not really two terms, it's just one. But the power applies to each, the x and the y, in the exponent. This is a pretty common case where people will take that a and write them as coefficients. Okay, so be very careful how you apply that a here. So what it ends up looking like is x to the power of a, y to the power of a. Okay, so be very careful. So if we come up with an example, let's say we've got 2x squared. Okay, very similar. So the x is basically represented by the 2, and now what was y becomes x. So those just got switched. Now if we use the same rule to write this out, this will become 2 squared x squared. And one more step we can do to simplify that, this will become 4x squared. Okay, so be very careful with this one and how you apply that exponent to everything inside. Okay, power of a quotient, number 5 is the one coming up here. So we need a quotient. Remember what a quotient is? It's division. Okay, so this is very similar to the power of a product, except we're going to be dealing with division, obviously. And the exact same rules apply. So in our power of a product, that exponent of a went to both x and y. In our power of a quotient, it will also go to both top and bottom here. So if it's a quotient, it's a little bit easier to think about because that exponent needs to apply to everything on the top and everything on the bottom. So for our example, let's say it's 3 to the power of 5. The whole thing is cubed. Now that's a little bit tougher to deal with, taking 3 to the 5, or 3 over 5, multiplying with 3 over 5, multiplying with 3 over 5. It's a little bit easier to think about it if it's 3 cubed over 5 cubed, because we know how to simplify that quite easily from our last video on cubes. I could say this becomes 27 on the top and 125 on the bottom. That's 5 cubed. Okay, so there you go. Now our zero exponent is a really nice one. As long as you have some rational base to the power of 0, that entire expression just becomes 1. Okay, example's quite easy also. 2 to the power of 0, that's also 1. So we won't really get into why that works in this video. It'll just take up too much time, but there are a lot of good resources out there, and I can even put a link to one in the description on why the zero exponent works out to be 1 for anybody that wants to look that up and really get into that. So let me just make a note here for myself to add that. And I will put that in the link for everybody. So we'll do just a bunch of examples now. I don't think I'm going to do every single one. These ones are really quick, so I think I'll do all of them in example 1 here. They're really fast. But some of the other ones later on, I might not. I haven't decided yet. So we'll start here. So example 1A, basically it just says to simplify the following exponential expressions. Okay, so we're just going to use all the rules we came up with and simplify these. So at the top, we see we've got an x to the power of 5. We are multiplying with an x squared. The rule there was if you're multiplying with the same base, my bases here are x, we add the exponent. So this becomes x to the power of 7. Simplified, we're done. Okay, for b, m to the power 7, divide m to the power 3. So again, same base. This is our quotient law, or for our exponents. So we're going to subtract those powers there since we're dividing. So 7 subtract 3 is going to give us 4. So this simplifies to being m to the power of 4. For c, I've got a product inside my set of brackets. It's raised to a power. So this is our power of a product rule. And we're going to say we've got a to the power 4, b to the power 4. And this one's simplified. Nothing else I can do here. I don't know what a and b are, so we can't solve for anything. Don't have an equation. So really, we are just simplifying. Okay, on to D. I've got a quotient inside the set of brackets raised to a power. So this is going to become x squared over y squared. Okay, whatever is in that exponent goes to both top and bottom in the exponent place. Okay, for E, again, same base as 7. I am multiplying. It looks a little bit different than A. If you remember, I actually had that multiplication symbol. But here, we've just got two things in brackets side by side, and in math, we know that means to multiply. So 7 as our base, 5 as our exponent, 2 as our other exponent. If we're multiplying with the same base, we add those exponents together, so 7 to the power of 7. Okay, this is F, so 6 to the power of 0. We just saw our 0 exponents equal to 1. So this one is completed, literally no work to do, which is some of these are really nice if we remember those laws and how they work. Now for G, it looks very, very, very similar. I've got -6 this time in brackets to the power of 0. So as long as whatever is to the power of 0, that's all contained in one, basically your one base, that whole thing equals 1 again. Even though it's -6, the negative's inside the brackets. So that 0 exponent applies to everything inside that bracket. So this is going to be 1 again. But for H, we're going to see things change slightly. So now there's no brackets, still a -6, still to the power of 0. So if I rewrite this one a little bit differently, technically this is -1 multiplied with 6 to the power of 0. Okay, the brackets here, or the lack of brackets, I should say, means I can actually separate the negative from the 6. In example G, the brackets enclosed the negative and the 6, which meant they were combined and I couldn't separate them. Since I can separate them here, this actually means -1 multiplied with 1, because 6 to the power of 0 is 1. So this one actually simplifies to -1. Now that's very different. Now for those of you that try to put this in on your calculator, you will see and you will notice, and I can even pull mine up here. Actually, 84 I've got. Actually, let's do this. You can see all my games on the side there. I kill all my time. Okay. Let's do this. So if I actually put in the set of brackets, -6, power 0, you'll see that it's 1. But if I leave the brackets out, you get -1. So your calculator is actually recognizing that the brackets are there or not. Now, you need to be cognizant of which example you're trying to do in your head. So if you're just going to straight up use your calculator for it and ignore the brackets, it won't work for you. So be very, very careful if you see a case like this. Okay, so let's take on, this is the last one here, example I. So 3 multiplied with x to the power of 0. Now this is again very similar to the one before it. Since there's no brackets, that 0 only applies to the x, not the 3. Okay, so anything to the power of 0 is 1. This one simplifies to 3 for us. So again, just be careful of the brackets and the way that the question's set up. Okay, so those were relatively straightforward, just straight up using those laws, one each. So I didn't have to combine laws for any of these. It really was just pick the law that worked and go from there. But of course, math is not that straightforward all the time. So we got to talk about some of the cases where maybe I have to use 2, maybe 3 laws to make this work. So before we do that, this is where you get actually one of those new exponent laws. The previous 6, many people would have seen in grade 9 for sure. This one, new and exclusive to grade 10 math. So we'll complete this pattern below. I'm actually going to use my calculator here as well to talk about some of those things. So 2 cubed, relatively straightforward. That's going to give us 8. 2 squared, 4. 2 to the power of 1, 2. Anything to the power of 0 is 1. But here's where it gets a little iffy. What happens when I have a negative exponent? So we're actually going to plug that in and see what happens. So 2 to the power of -1, I actually get a fraction, 0.5. Now I'm going to write it as a fraction. And if you don't know how to do that, on your calculator, there should be a math button to the left. The first one turns whatever you have, so math 1 turns whatever you have as your answer into a fraction. A lowest terms fraction, if possible. So whatever fraction you see come up, that's your lowest terms reduced fraction, which is very, very nice for some of those other numbers that might come up. So a half is our fraction. 2 to the power of -2. Well, I know what 2 squared is. I know it's 4. So let's see what 2 to the power of -2 is. 0.25. Now I'm going to turn that into a fraction as well. And you'll see that it's 1 over 4. So that's kind of interesting. 2 to the power of -3. If I kind of think about how this is going, I went 8, 4, 2. So I'm going the other way. 2, 4, 8. 2, 4. I think this one should be an 8 as well. So let's actually check it. 2 to the power -3. 0.125. Now, our number sense savvy and math decimal savvy people will already recognize that as 1 over 8. But if we need that little bit of practice and reassurance, our calculator will help for sure. So I've got my 1 over 8, just like I thought. Now, that's very interesting, this pattern, because when you actually look at it, 2 to the power of 1 was 2, but 2 to the power of -1, we see that 2 actually go to the bottom part of a fraction. 2 to the power of -2, I see my 4 on the bottom, but 2 squared, I saw 4. Okay, and the same thing is true for 2 cubed. Essentially, there's a word for this. Now, 8 can actually be written as 8 over 1. It's just a fraction. All I did was divide it by 1. That changes nothing. But in order to get 8 over 1 to look like 1 over 8, there's a word in math that we talk about when we flip something. Now that word, reciprocal. Okay, so I can always take the reciprocal to deal with this. Now we'll formalize that and put it actually into a sentence. So the result that comes out of this is if I have a negative exponent, I can rewrite that as an expression that has a positive exponent. And the way I can do that is by taking the reciprocal. So there's a couple ways that we could do this. So let's just say straight up, I can take the reciprocal. Of the expression with the negative exponent. Okay, so I'm actually going to talk about one of these ones up here first. And I'm going to talk about 2 to the power of -3 before we get into the ones down below, which you already saw there. So let's talk about 2 to the power of -3. Now, what that statement just said, the ones that we wrote together, taking the reciprocal of that expression, this 2 to the power of -3 can be written as 2 to the power of -3 divided by 1. Now, if I take the reciprocal of that expression, literally flip it over, what was the numerator becomes the denominator and vice versa, this will now say 1 over 2 to the power of +3. And that's where I'm getting that 1 over 8 from. Okay, the other way you could do this, if you wanted to get to your simplified form, calculate what the positive exponent would be, and then take the reciprocal. So 2 to the power of +3 is going to be 8, then flip it over to get my 1 over 8. So whichever method you choose really doesn't make a difference, but as long as you're taking that reciprocal somewhere to take care of that negative power. Okay, so when you're asked to write something as a positive exponent, it doesn't necessarily have to be in the numerator of your fraction. It can be on the bottom, but be very, very sure that the exponent is positive. We don't really like leaving negative exponents in an expression. Okay. So this is what we'll try to do. For the same reason we don't like leaving negative signs, like for a negative value in the bottom of a fraction. Usually by convention, it's moved out to the middle or up to the numerator. Okay. Now be very, very careful. This is a really common mistake as well, that people will say that a negative sign, oops, I can't write today. Negative sign is not the same as a negative exponent. Okay, those are very different. And we'll see that in a couple examples down below. So again, actually, I think I will do all of these ones because they are relatively quick. but maybe the ones down below, I don't think I'll do the challenge ones. I'll put them up in the description with the full answer key, but I don't think I'll take the time to do them on this video here. So I will write them out for you down below. So if you want to try them out, by all means. If you want to try out any of these before I actually do them, just, pause the video, try them out before you watch me do it, and then see how you did when you rewatch it. So let's go take a look at these. So for example, 2, we are going to rewrite the following expressions with positive exponents. So we're basically going to simplify it. So here's my first one, 3 to the power of -2. Now we want that to have a positive exponent. So before we learned that I could take the reciprocal of it and write it as 1/3 squared. And if you want to keep going, you can say that's 1/9. Technically, this does have a positive exponent of 1. So there's A all taken care of. Now for B, here's where that important thing will come in that I wrote in red just above. So a negative sign, like you see in front of the fraction, is not the same thing as a negative exponent. You can have negative signs, that's no problem. Negative exponents, however, we're going to try to make positive. So we again can take the reciprocal and we can make the exponent positive, not the negative sign, not the value of it. So we're actually going to leave that negative sign alone. And we're going to take the reciprocal, 4/3. But this time, it's actually to the power of +3. Okay, so there's my expression, simplified, positive exponent. Negative sign, which is fine, but positive exponent. So be very, very careful. Okay, for C, I'm going to do a little bit of rewriting here. So instead of it saying 0.3, I know that as a fraction, that's 3/10. Now that's to the power of -4. We need it to the power of +4, positive exponent. So take the reciprocal, flip it, 10/3, and this becomes to the power of 4. Okay, nothing else to do. We just had to get it to a place that has a positive exponent. So C is taken care of. Okay, let's look at D. This time, my negative exponent is actually in the bottom. So same rules apply. Take the reciprocal to get rid of that negative exponent. All of the other ones we've done so far has been taking that negative exponent that's usually in the top part, taking the reciprocal, making it positive. But here we can flip this entire fraction. So it becomes 25 squared over 1. Now, 25 squared is easy. That's 625. So there's your simplified answer. Positive exponent of 1, all taken care of. Now, for a lot of these, you can actually double check in your calculator, provided you actually put them in correctly with brackets. So if I do 25 squared, right, I get my 625. So let's check out what the original expression is. This is a good way to double check. So 1, divide, and I'm going to put a set of brackets. 25 to the power -2, close the bracket. And, oh, I forgot to put a negative, that's why. So let's go back into this. Let's try it again. 1 divided by bracket 25 to the power -2. Now I get my 625. So I forgot to put the negative in the first time, which does happen. We do make mistakes. But there you go. It does work out the same way. So 25 squared is the same as that original expression. So you can always try to plug them in your calculator to double check you're doing them correctly. Okay, for E, very similar. I've got my, this is a quotient, a power of a quotient rule. But I don't really want to apply the -2 inside because it's a -2 and I want the positive exponent. It makes it a lot easier to think about. So we'll take the reciprocal again of our fraction, 9/25. That's going to be squared. So if you really want to get going and simplify further, you can then do 9 squared over 25 squared, which is going to give you 81/625. Okay. And I'll do this one more. So there's F. Again, 27 to the power of -3. Take the reciprocal, make that exponent positive. So this will be 1/27 cubed. Again, should be a really large number. 27 cubed should be a large number, but 1 over that 27 cubed will be a very small number. So there you go, is how we can use those negative exponents. Now, for example, 3 comes all the fun ones, because this is where people will start to struggle. because we're going to have to use all of those exponent laws, we might have to use multiple in the same question to simplify it. People start to mix them up and try to put things together where they can't. So for this part of Math 10 especially, practice becomes super, super important. So all the examples and questions that you can find, the better, because there's an infinite number of them. If we just combine laws, change numbers, we can even use variables to do these. So we'll start here. So here we go. Simplify the following and leave it with positive exponents. So I've got a -4, and I've got an exponent of -2. Now remember that there's no brackets. So technically that negative is separate from the 4. And I guess I should say that's a -1. So we know how to deal with 4 to the power of -2. We can take the reciprocal and we can write it as a positive exponent on the bottom. So that's going to be -1 multiplied with 1/16, which is really going to tell us it's -1/16. Okay, there's the first one simplified. Positive exponents all around. Negative signs are okay. Just remember that a negative sign is not a negative exponent. They're different. So the 1 has a positive exponent of 1. The 16 also has a positive exponent of 1. Okay, this one's taken care of. For B, it looks complicated, but it's not. You can deal with it a couple ways. I'm going to just show you one way rather than 2 ways. So I'm going to leave that 2 to the power of -2 alone. I know that 2 to the power of 0 is just 1. So it'll be this 2 to the power of -2 multiplied by 1, which I don't really have to write multiply by 1 because it doesn't change anything. So this is technically what I've got left. And I think I just wrote an extra brackets. So let's just do it this way. Okay. So now I've got a power to a power. The rule there is you multiply those exponents together. So this actually becomes 2 to the power of +4. Okay, and that's all taken care of. Okay, you could actually evaluate it as well and get 16. Because 2 cubed would be 8, multiplying by 2 again would give us that 16. So there it is, all taken care of. Okay, for C, I've got a power inside my set of brackets raised to another power. So this one becomes 5 to the power of -8 when we multiply those exponents together. But again, I've got a negative exponent, which I don't really like. So we're going to make that a positive by taking the reciprocal and writing my exponent as a positive in the denominator. Now, I don't really want to evaluate that because I think it'll be quite large. Let's just see. Yeah, I don't really want to write that. So I'm going to leave it as 5 to the power of 8. Totally fine, because I have left my answer with a positive exponent. So we're good. For D, take a look at this one. So I've got quotient, I've got powers, and I've got them raised to another power. So I've got a couple things going on. And there's 2 ways I could do it. I could apply that -2 to top and bottom first. Or if I look inside the brackets, it's actually a base 3 on the top, base 3 on the bottom. So I can actually subtract those powers first. So let's do that. So this is going to simplify to being 3 to the power of -2, still to the power of -2, because 3 minus that 5 gives me my exponent of -2. Power of a power now, I can multiply those exponents together. This will give us 3 to the power of 4. That's equal to 81. 3 cubed is 27. Multiply that by 3 again, you get your 81. Okay, so really it is only 2 steps, but I did have to use 2 laws here. If you do it in a different order, you might have to use other laws to solve it, but you will get the same result of 81. Okay, if I look at E, there's my 3/2. As a fraction, there's my quotient to the power of -2. So we're going to take the reciprocal and then change my exponent to a positive. So I'm going to take the reciprocal of this fraction. So 2/3. And that'll become +2. Now I can apply that inside. It's quite nice. 2 squared will give me 4. 3 squared will give me 9. Okay, we can double check this as well if we're really skeptical. So 3/2 to the power of -2 gives me this fraction. Make sure that is 4/9. and they are identical. So we know we did it correctly, okay? And F looks like the last one now. Doesn't look great, but take it piece by piece. Don't take it as the whole thing at once. It looks very overwhelming. So start small. So we're going to look inside the brackets first. So my quotients are the same, 2 over 5 and 2 over 5. That means my bases are the same. My exponents, however, are different. I am multiplying. If I multiply powers that have the same base, we add the exponents together. So this inside the brackets, all it simplifies to is a 2 over 5 to the power of -1. But remember, we've still got a power of -3 on the outside. Okay, so that was the inside of the brackets. -3 plus 2 was -1. My -3 is on the outside. Now this is really a power of a power rule. So I can multiply those exponents together now. So again, piece by piece, take it slow. And that's going to be +3. Negative times negative makes a positive. 1 times 3 is 3. Now I can apply that 3 into this quotient. So remember, our quotient law tells us it goes to the top and to the bottom. 2 cubed is 8. 5 cubed, 125. So there you go. There are a ton of resources online that you can find. Just type in exponent laws math 10, hit enter. And you will find a lot of practice. It usually has the answers as well. So I will get those challenge ones in the solution key. If you want to try them out, by all means, that's what they're there for. And again, if you do need some help, you have any questions about anything I didn't hear, please leave a comment, send me an email, and I will do my best to get back to you and answer that question for you. So look out for the next video that's going to come out. I don't even know what it's on. I think, oh, then we get into rational exponents. So now we did integral exponents. So all of our exponents were integer values, so whole numbers with either a positive or negative sign. Rational exponents, we could have fractional exponents as well. So 3 over 2 as an exponent, 3/4 as an exponent, something like that. So it doesn't change any of the laws, but it just brings in with that extra element of difficulty when you have to deal with fractions. So that's what we'll talk about in the next video when that comes out. So again, please let me know. Ask your teachers if you have any issues. Tell people about this if it actually helps you, because then I feel like I'm doing it for nothing. But we will see you next time in that video when I figure out how to end this. Okay.